We're going to call this writing formulas for ionic substances. There's paper in the back. In the box in the back. And in parentheses, I'm going to write also known as salts. So writing formulas for salts. All right, so you know that question I gave you for homework last night with the aluminum and the oxygen? Yeah. Did you struggle with that a little bit? Yeah. Well, it could have been easier for you to do if I showed you what I'm going to show you next. Okay? I gave it to you on purpose because I wanted you to feel the struggle a little bit. Okay? Did you? Oh, get out. Okay. Oh, stop. Hey, in life there aren't any victims, just volunteers. You make yourself a victim. Right? Hey, stop. It is being recorded. Don't ever put yourself in the position of being a victim is what I'm telling you. Keanu, no, I'm not saying that. What if I wanted to figure out the formula for the compound made between magnesium and nitrogen, and I was too lazy and I didn't feel like drawing these pictures? No, you don't look it up. You're not going to be able to look it up. Stop. Don't be dirty. All right, anyways. We have a way of coming up with the formulas without having to draw the dot structures at all. I made you draw the dot structures on purpose because I wanted you to understand the whys and the hows. Like, why does it come up with the particular ratio of Al2O3? Why there's 2 oxygens and I'm sorry, 3 oxygens and 2 aluminums? But in reality, that whole process of drawing these pictures is very long-winded, right? And kind of drawn out. Yeah, Evan, what's up? Yeah, yes? That's exactly where I was going with this. Okay? So, you don't necessarily have to draw the pictures. Alright, what you could do instead, guys, come on, I don't have time, it's Wednesday. What you could do instead is start by writing the ions involved with their charge. You have to include the charge. And that's why I asked you to memorize that. So, what are the 2 elements that we're talking about here? We're talking about magnesium. Right? And what's the charge for magnesium that you memorized? It's in the second column on the periodic table, so it would be 2 plus. And then the other element is nitrogen. And based on its location, what was the charge that I asked you to memorize? No. Okay, remember you have your periodic table? Right, it's 1 plus, 2 plus, 3 plus, 4 plus or minus, and then nitrogen is 3 minus. Okay, so you start by writing those ions involved with their charges. And then the second thing that you do is you crisscross the charges. All right? And what I mean by crisscross is that the charge on the cation becomes the subscript on the nonmetal, and the charge on the anion becomes the subscript on the metal. I'm scooching it up. Okay? So, charge on cation becomes subscript of nonmetal. Charge on anion becomes subscript on the metal. You don't know what a cation is? Go back to your notes for chapter 1. Look in the glossary of your book. No. You're asking me something that you should have mastered a long time ago. What is a cation? It's the positive one. All right, now, watch. Put your pencils down and watch. You can finish copying this in a sec. What do I mean? This charge tells me how many of those guys I need. This charge tells me how many of those guys I need. So my formula is Mg, how many magnesiums? 3, N, 2. All right? We have a lot more of these. Okay? We're going to do it several more times, Nick. Okay, so we're going to do some practice things. Okay? So we're going to write formulas for substances that form between yes, sir. Yes, sir. Okay, just watch. Watch. How about we do the aluminum and oxygen? That same one that we had to do in number 10B that you guys had a little bit of a tough time with drawing the mechanism for. Okay? All right, so what if I wanted to figure out the formula for that substance that forms between aluminum and oxygen without having to draw those pictures? So let's start with writing the ion for aluminum. What is it? What's the charge on it? You memorized it. Okay, and if you didn't memorize it, Nick, I like what you're doing. What are you doing? That I made you write it on yesterday? Ooh, that's great, right? Because I did give it to you for a reason, not just for you to shove it in your notebook and not look at it ever again. What about oxygen? Is O with what charge? Okay, Nick, put your pencil down and watch. This charge tells me how many of those guys I need. That charge tells me how many of those guys I need. So it's Al2O3. You always write the metal first. Okay? Now, isn't that the same formula we got by drawing out that picture yesterday? Yeah, much quicker though. All right, let's do another one. How about between lithium and oxygen? It is. It is really, my dear. Okay, lithium and oxygen. What's the formula for lithium? Li 1 plus. And what's oxygen? O 2 minus. So crisscross here. Li 2 O. All right, let's take a look at another one. Aluminum and chlorine. Say what? I mean, it's understood that there's a 1 there. You don't have to write it. No. No, if it helps you, that's fine. Put it there. What about aluminum and chlorine? It's Al3 plus coming together with Cl1 minus. So when you crisscross, what do we get? AlCl3. All right? Let me give you one more. And this next one I'm going to give you, we're going to add a rule to this. Okay, so in the margin, I'm going to add a little rule here. I'm going to put a little box, rule. Okay. Magnesium and oxygen. So let's have you guys start it. So what's the ion for magnesium? Mg2 plus coming together with O2 minus. So when you crisscross, what do you get? Mg2O2, right? Yeah, we don't leave them like that. The actual formula really becomes MgO. All right? Okay, so what did I do? What did I do? Guys, stop fighting. What did I do? I reduced. All right? So ionic formulas are simplified or reduced at the end. Ionics reduced at the end. All right? So I put in a little box. I'm going to highlight it. Make sure you see that this is something that's important. Now, it's only for ionic things that you reduce. When we get to covalent substances, you don't reduce those at all. Okay? All right. And so what you do is you look at the subscripts. If they're divisible by the same number, you just divide it out. All right? Let's do some other questions that I need you to do, similar to what you have to do for homework tonight. I think, again, it's on page 214. What does it say on the board? Actually, you got questions out of 3 different pages tonight. So on 214, you have to do number 44. On page 273, you do number 10. And on page 298, you do number 66. Let me show you some other things that they're going to ask you, all with the same idea in mind. Okay? What if they want you to go backwards now? And they want you to write the formulas for the ions present in certain substances. Yes. So, like, for instance, in CaCl2, what if I gave you the formula first and I asked you to work backwards? You do?
Yes.
Tell me.
All right, so for that first one, is that
CaCl2,
CaCl2?
yep.
So it would be,
What are the 2 ions there?
it would be Ca, or it
Ca?
would be Ca2 plus,
Uh-huh.
and then Cl1 minus.
Excellent. How'd you do that, Nick?
Because since like Ca is 2 plus so
You just looked up the periodic table and the charges you memorized.
yes.
Works for me. Okay. How else could we have done this? Patrick. Yeah, a different way. Nick. Okay. So is that the first guy's plus, the second one's minus? Well, how do you come up with the numbers, though, on the charges? You undo the crisscross?
Yes.
Right. So, like, this one becomes the charge of that guy, this one becomes the charge of that guy, and then you memorize that the first one in the formula is a positive, the second one is negative. So basically you undo the crisscross. You undo the crisscross, remember the cation comes first. Remember positive ion is first in the formula. Alright, so what if you had this next one, Fe2O3? What are the ions there? You got it? Give it to me. Uh-huh. You got the number right, but your sign. Okay, so we undo it, right? So the Fe is going to be a 3. It is plus. Uh-huh. O2 minus. Because the positives are always the first ones. Let's do another one. Na2O. Right? When you undo it, this charge is that guy's, that one is that one's. And if there's nothing there in the bubble, what do you assume? It's a 1. And the metal's always going to be the positive guy. Okay? Alright, let me show you one more thing. Okay? Now we're going to do things with polyatomic ions. Well, what is a polyatomic ion? Well, I'm not going to totally explain to you what it is today. I'm simply going to tell you that there are some ions in nature that exist that have more than one element in them. All right? And at the end of the week, you're going to have to memorize a list of these, because next week I'm going to give you daily quizzes on these. So, for example, what if I wanted you to write the formula between magnesium and the polyatomic ion that we call nitrate? All right? Okay, well, what's the formula for the ion of magnesium? Mg. What's the charge on it, honey? Excellent. And now I'm going to tell you today what nitrate is, because I haven't asked you to memorize these yet, right? Nitrate is NO3 1-. So we call this a polyatomic ion. So it's an ion that has more than one atom in it. This one in particular has 4 atoms, 1 nitrogen and 3 oxygens. Well, how do I come up with the formula for that? How do I do the crisscross for this? Well, guys, just pencils down, just watch. When you have polyatomic ions, it helps if you put parentheses around them and leave the charge on the outside. All right? So the charge is out here on the outside. Okay, now do the crisscross. This charge tells me how many of those guys you need, and you put that number outside of the parentheses. That charge tells me how many of those guys I need. So what would the formula be? Mg, how many Mgs? One of them. I don't really need to write the one, but if it makes you feel comfortable, do it. And then what? NO3 2? Like that? No. What's wrong with that? That shows you that you have 32 oxygens. That's asinine, right? So how do you write it? I told you to write parentheses. There's a reason for that, because I want you to leave the NO3 in parentheses. Now, how many oxygens are there really if you put parentheses there? 6. 3 times 2 or 6. How many nitrogens are in there? 2. It's like distributing in algebra, right? You multiply. Okay? All right, let's do another one. How about between lithium and phosphate? Lithium and phosphate. Well, what's the symbol for lithium? I know you know this one. Li1 plus. And phosphate I'm going to help you out with. Yeah, it is phosphorus and oxygen. It's got the formula PO4 3 minus. All right? So what would the formula be if you had to cross these two? You got this? Uh-huh. Okay. Uh-huh. PO4. Parentheses. Yeah. Yeah. No, not quite. What? Okay, what happened? You forgot lithium. How many lithiums do you need? 3. Okay, so again, put parentheses around that polyatomic ion, leave the charge on the outside, and then physically, if you have to draw the arrows, draw them, crisscross, right? So how many lithiums? 3. How many phosphates? Right, so the formula is Li3PO4. Let me show you something else. And I just want you to watch. Aluminum and phosphate. And we'll add another little rule over here. Okay, guys, don't move. Aluminum is Al3+, phosphate's PO4 3-. When you see that the charges are the same value but different sign, what do? They cancel. When your charges cancel, just shove all the letters together. So what would the formula be? AlPO4. Okay, so the rule is if the charge is the same, just shove the letters together. Okay, guys, don't forget to do your homework tonight. So if the charges cancel out, just shove letters together. Bye. Have a good day. You too.